Assalamualaikum and a very good evening. Hi, my name is Mohamed Iqbal Muhammad Ruslan and I'm from group A15. Today, our group will be presenting about the sedimentation experiment. For my part, I will be doing the introduction part. Sedimentation is a tendency for particles in suspension to settle out of the fluid they are entrained in. It happens due to motion through the fluid, which is caused by the forces that act towards them. Settling, on the other hand, is the falling of suspended particles through the fluid. They settle down to form a sediment. Particles that experience a force will move in a uniform direction in which the force they are exerted in. A particle at rest will exhibit no drag force, which causes the particles to accelerate due to the applied force. As the particle's velocity increases, the drag force and the applied force will eventually equate, retarding the particle's velocity. This is known as the terminal velocity. Terminal velocity is dependent upon grain size, shape, and density of the grains, and also the viscosity and the density of the fluid. Right, for the theoretical part, this is what we are doing in our experiment. The solid is uniformly distributed in the liquid at the beginning. The total depth of the suspension is equal to Z0. After a while, the solid settles to give a zone clear liquid, which is zone A. In our experiments, there are 4 different zones, namely zone A, zone B, zone C, and zone D. Now, as the experiment continues, the depth of zone D and zone A increases as settling continues. The depth of zone C remains nearly constant of that at zone B. Eventually, zone B disappears and the solids are all in zone C and D. The gradual accumulation of solid puts stress on the material of the bottom and compresses solid in zone D. After a while, it breaks down the structure of the flocculants and liquid is expelled into the upper zones. Lastly, when the weight of the solid is balanced by the compression strength of the forces, settling stops. This is where sedimentation occurs.
Yeah, Bismillahirrahmanirrahim. My name is Nazar Shazam Yazmi. I'm from group A15. For our experiment, my part, I'm going to tell you a bit about the abstract of this experiment. The objective of the experiment is basically to study the effect of the height and also the concentration in sedimentation process. Okay, in the experiment, we are actually manipulate the initial concentration of each of tube, which is 5 tube, and we will determine the height of the substance through time. Okay, this is the first part of our experiment. On the second part of our experiment, we are going to do the same experiment but with the presence of flocculant. As you can see, the function of flocculant is to increase the efficiency of settling, clarification, filtration, and also centrifugation. By the end of experiment, we can see that with the presence of the flocculant, the rate of the settling increase much more bigger compared to the experiment without the flocculant. I think that's all for my part.
Okay, next I'm going to talk about the results for this experiment. For experiment A, the interval of 5 minutes is used to tabulate the data. For each cylinder, the height of clear liquid interface is being tabulated in this table. And from this bar chart, it is clear that cylinder 2 has the slightly higher Z compared to cylinder 1, which means cylinder 2 has the highest among all the 5 cylinders. And this graph shows an inverse exponential, which is when settling time increases, the height of clear liquid interface is going to decrease. And next, the experiment B is an addition of flocculants into the cornflour solution. It is tabulated in the same manner as experiment A, which is in an interval of 5 minutes, the height of clear liquid interface is going to be tabulated in this table. And from this bar chart, it is also having the same trend as the experiment A. The difference is very small and it is not obvious for you to see actually. And from this graph, it is having the intersection at the cylinder 2 and 1 in between of them, whereby the cylinder 2 at certain point it intersects with the cylinder 1. From these two experiments, it is clear that as the sedimentation rate is very slow, it actually takes longer than 30 minutes for the sedimentation to occur completely. And the addition of flocculants into the cornflour solution has actually increased the sedimentation rate for the experiment B. And the overall experiment, the overall sedimentation rate for experiment B is higher than experiment A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nolena bin Hassan. Today I will explain about the methodology of our sedimentation experiment. First of all, the experiment is divided into two parts, which is experiment A and experiment B. Moving on to experiment A, which is the sampling rate for different initial heights and concentrations. For your information, the initial heights and concentrations of each solution in the cylinder is different. The solutions are being prepared using corn flour in 2 liters of water. So this is the amount of flour used in cylinder 1, 2, 3, 4, and 5. And then the solution is slowly poured into each solution. And the height of the liquid interface Z is being recorded for every 5 minutes until 30 minutes. The results are then tabulated in tables and the graph are being plotted. And then moving on to experiment B, which is the sampling rate for different volume of flocculants. The heights and the initial concentrations of the solutions are the same as the experiment A, but the difference is we need to prepare flocculants by using 2 grams of aluminum oxide in 100 ml of water. And the same amount of corn flour are used in each cylinder, but different is we need to add flocculant into each cylinder, cylinder 1, 2, 3, 4, and 5. And then the solutions are being poured into each cylinder, and the height of the clear liquid interface Zs are being recorded for every 5 minutes until 30 minutes. And the results are tabulated in tables, and lastly the graph are being plotted. That's all. Thank you.
Good evening everybody, my name is Manisha Kumar. Now I'll be talking about discussion. This experiment studies the effect of different initial height and concentration and the effect of different volume of flocculant on the settling rate. In experiment A, the settling rate of different initial height and concentration. In part A, different solution with different concentration and different initial height is filled in each of the cylinder. From the result obtained, it is shown that with the same concentration, the settling rate is faster when the initial height and solution is lower. This may be due to the gravitational force. On the other hand, when the solution concentration is higher, the settling rate is slower compared to the
Boleh.
On the other hand, when the solution is when the solution concentration is higher, the settling rate is lower compared to those having a lower concentration. This is because when the solution is having a higher concentration, the molecular of the solution are located nearer to each other, which give less space for the molecule to move into each other. The settling velocity for each solution is not constant throughout the experiment. It can be observed from the result. As you can see, in each 5 minutes of the interval, the settling rate might
Ha?
Obvious sangat tak pandang.
Tak.
Now I'd like to continue with experiment B. Experiment B is the settling rate for different volume of flocculant. In part B, we have added different volume of flocculant into each cylinder of the chemical. This cylinder with the same solution used in experiment A. Flocculant consists of various molecules with anion, non-ionic, and cation polymer. They are used to increase the efficiency of the settling, clarification, filtration, and centrifugation operation. The function of flocculant is to bring together coagulated particles into larger aggregation and settle them. Flocculation occurs after the addition. Flocculant occurs after the addition of chemical to the destabilizer that charges on the colloidal particle in suspension. The particles adhere to each other via the flocculant ion on the surface of the particle. This changes the ion provided on the opportunity for charged particles in a system to adhere to them, thereby merging individual particles. This result is larger and denser flocculant that settle more rapidly. After a certain long time, the sedimentation process will stop and the process is completed. It has fully absorbed everything. This process is said to be at equilibrium. From the result obtained, the data is not consistently supported by the theory, which might be due to some error in the experiment. Now I'd like to